Okay.
No.
I'm sorry.
That's why I'm glad you moved.
Mm-hmm. Oh.
You're no longer by yourself.
Okay. So, wow, it's like really acting weird. All right. So this would be, since plus, we use the top one. So it's the sine. This is A and B. So it's the sine of 225 times the cosine of 60 plus the cosine of 225 times the sine of 60. Okay, good with that part? All right. So we're going to need the sine and the cosine of 60 and 225. We already have sine and cosine of 60. We did that earlier. No, we didn't. I lied. Just kidding. I'm sorry. I'm going to have to turn this off and then turn it back on because it's lagging really bad. There we go. Oh, it didn't even drop. All right. So 60 degrees stays there. Across from the 60 is the square root of 3. The adjacent side.
Martha, come to the office, please. Martha.
And the hypotenuse is 2. Very good with that. So the sine of 60 is square root of 3 over 2, opposite over hypotenuse. And the cosine of 60 is 1/2. All right. Then over here for this 225, we have the opposite side of 45 is -1. It's going down. The adjacent side is +1. It's going to the right. And the hypotenuse is always positive. It's square root of 2. So the sine of 225 is opposite over hypotenuse. So it's -1 over square root of 2. And the cosine of 225 is the same thing, only it's positive. No. Why doesn't anybody say anything? That's negative because I went to the left. Y'all, I knew you knew that.
I was making sure you knew.
Yeah, okay. I was just checking to see if you knew. I got to thinking, I was like, wait a minute, tangent is the only one that's supposed to be positive in the third quadrant. What? Okay, so when I add those, and I'm going to use this. What was the sine of 225?
-1
Thank you. And the cosine of 60? 1/2. Plus cosine of 225 was also -1 over square root of 2. And the sine of 60?
Square root of 3 over 2.
So top comes top, bottom comes bottom. -1 over 2 square root of 2. Plus negative square root of 3 over 2 square root of 2. So you get -1 plus negative square root of 3 or minus square root of 3 over 2 square root of 2. Good? Okay. So let's look at the next page. So we're simplifying each of the following expression using the sign sum or difference identity. I'm sorry you got beat up while you're over there. Okay, so we know if you look back at the other page, and back to it, two things added together. So that's the sine of a plus b. So it's the sine of x times the cosine of 2 pi over 3 plus the cosine of x times the sine of 2 pi over 3. So we got to figure out the cosine of 2 pi over 3. And the sine of 2 pi over 3. So 2 pi over 3, what should I do first? I'm going to take that phone and I'm going to throw it outside. No, not yours. It was Cameron's, because Cameron was on it. What? Yeah. We want to change it. I'm not really good. So I'm going to change it to degrees. It is 120. Excellent. Whoa, I did not mean to do that. Oh. What? Oh. There we go. All right. So 120 is in the second quadrant. What's its reference angle? This one. 60. Those two angles got to add to equal 180. So that's how we knew it was 60. So across from the 60 is, let's see, square root of 3. The adjacent side is -1. And the hypotenuse is 2. So I need the cosine and the sine of 2 pi over 3. Sorry, my it's just being crazy today. There's an update I missed. Oh, I got rid of all that. Alright, so cosine of 2 pi over 3 is what?
-1 over 2.
Good. And the sine of 2 pi over 3?
Square root of 3 over 2.
Excellent. Bear with me. Alright, sweet. So we're just going to plug that in. We have the sine of x, cosine of 2 pi over 3, I guess -1/2. Cosine of x times the sine of 2 pi over 3 is square root of 3 over 2. So that becomes, if I do top times top, it's negative sine of x over 2. It's -1 times the sine of x. And then plus square root of 3 times the cosine of x over 2. We have a common denominator. So I'm going to write the positive one first. Square root of 3 times the cosine of x minus the sine of x over 2. So it looks complicated, but it's really not. It looks more complicated than it is. Okay, the next one is subtraction. So this is A and B. So let's see, Cameron, tell me what it is. Sine, cosine, what?
Like pi over 2,
Mm-hmm.
2 degrees.
No, like how I would rewrite it using the formula.
Sine pi over 2, cosine theta plus,
You can look. The page right before.
minus
Minus
cosine of pi over 2 times sine of theta.
Very good. Now, does anybody know off the top of your head what pi over 2 is? It's 90, yes. That's when we should know, and if not, we'll eventually know it. So since it's 90, I don't use a triangle, I use a unit circle. And pi over 2, or 90 degrees, is up here. So that point, to get to it, is 0, 1, because they went left to right, none, went up, 0. So the sine of pi over 2 is the y-coordinate. So it's 1. And the cosine of pi over 2 is the x-coordinate. It's 0. Sine is always the y, cosine is always the x on a unit circle, because the radius is 1. Okay, so plugging that in. Sine of pi over 2 is 1 times cosine of theta. Cosine of pi over 2 is 0 times sine of theta. 1 times cosine is cosine. And 0 times anything is 0, so it's just cosine of theta. Okay, I want you to open up your MacBooks, and there is an exit ticket that has popped up. And you're not going to be graded on accuracy. I just want to see where the problem areas are. So there's a problem on there. I want you to do it on paper and take a picture of it and upload it. You have plenty of time before the bell rings. When you're done with that, you're done.